All right, lesson 98 is finding the distance between 2 points and the slope formula. So, use the Pythagorean theorem to find the distance between 4, 2, and negative 3, negative 2. All right, so first I'm going to plot these on the graph. So I've got the point 4, 2 right here, and the point negative 3, negative 2 right here. And what we're trying to find is the distance from here to here. So what we need to do is draw a right triangle, and then we're just going to use Pythagorean theorem to find that distance. So I'm going to draw mine up. If you drew yours down, it would be the same thing. So let's do maybe the different color. So we've got from here to here, here to here. That one's kind of hard to see. All right. So what we need to know is how far is it from here to here, so I can do a squared plus b squared equals c squared. So the lowest point, what I'm really comparing here is my distance between the y's. So I went from negative 2 up to positive 2. So this is a distance of 4. All right. And then on my x's, I'm going from negative 3 over here all the way over to 4. So I'm comparing from there to there. So the distance all the way across here is 7. And so then we can do the Pythagorean theorem. A squared plus b squared equals c squared. So 4 squared plus 7 squared equals the hypotenuse squared. So that's 16 plus 49, which gives me which gives me 65. And then we're going to square root both sides. And so that distance is the square root of 65. If that simplifies, this is 5 times 13, so there's no perfect square number inside of it. So we're just going to leave it as the square root of 65. And remember, it's a length that we're talking about, so it's always going to be positive. That's why we don't have the plus minus in front. All right, find the distance between negative 4, 3 and negative 2, 5 and the slope of the line between these 2 points. All right, so you guys draw an xy axis, and let's plot our points. So I have negative 4, positive 3. Then we have negative 2, positive 5. And I want to find, oh, that's probably not very good. Let's try this. Okay, let's try the distance here. So I drew right triangle. So from here to here is a distance of 2. And from here to here is a distance of 2. Again, I can look and see the distance between negative 2 and negative 4 is 2. And the distance between 3 and 5 is also 2. So now I can do Pythagorean theorem. A squared plus b squared equals the hypotenuse squared. So this is the side we're finding. So 4 plus 4 equals c squared. So that's 8. And then we're going to square root both sides. This one does have a perfect square number because this is 4 times 2. And the square root of 4 is 2. And then the other 2 stays inside. And there we have the distance. Okay? So make note that this guy right here is the distance between them. We also need to find the slope. So that's a separate problem. So now I also am going to find the slope between the 2 points. So by looking at the graph, slope is the rise over the run. So how far up we went and how far over we went. So my change in y was positive 2, and my change in x was also positive 2. So my slope is 2 over 2, which reduces to 1. And you can look at the line. This slope has a positive slope because it's going uphill, so it's positive 1. All right, this formula is really important, so make sure you put this in your notes. So to find the slope between 2 points, so if we have a coordinate point, x1, y1, and another coordinate point, x2, y2, we find the slope by doing the change in y, that's what this triangle means, the delta, okay, change in y over the change in x. So we do the second y minus the first y over the second x minus the first x. So let's find the slope between 1, 2, and 5, 6. So I have x1, y1, x2, y2. Okay, so we use m for slope. So we're going to take the second y, which is 6, and we're going to subtract the first y, which is 2. So the 6 minus the 2. Divided by the second x minus the first x. So 5 minus 1. 6 minus 2 is 4. 5 minus 1 is 4, and we get a slope of 1. So let's try another one that has negatives in it. So find the slope of the line that passes through the point. So anytime you're doing these on your problem set, I do want you to write the formula down so you guys can memorize the formula. Okay? And then we're going to substitute in. So you might want to label x1, y1, x2, y2. So we're going to take the second y, which is negative 12, and we're going to subtract the first y, which is 7. And then we're going to take the second x, which is negative 14, and then the negative sign from the formula, and subtract 4. So negative 12 minus 7 is negative 19, and negative 14 minus 4 is negative 18. And if it reduces, you definitely want to reduce. But what we have is a negative over a negative, so I do want you to change that to a positive 19 over 18. All right, so what happens if we switch the order of the points? So let's say we put negative 14, negative 12 as our first point, and then 4, 7 as our second point. Is that going to change our answer? So let's see what happens. So we would take the second y minus the first y. Now be careful here when you subtract this minus this. So it's 7. We're subtracting, because of the formula, and we're subtracting a negative 12. So there's two negatives, okay? Then it's the x2 minus the x1. So the second x is 4, a minus from the equation, and we're subtracting negative 14. So these change to plus, and we get 19. A double negative here is going to change to a plus, and we get 18. So it does not matter the order of the points, but you need to be consistent. So if you're going to do this one minus this one, then you have to do this one minus this one. All right, so let's find the slope containing the following points. This one just kind of has a couple things that happen differently. So let's see what happens when we do these. So we're going to take the second y minus the first y over the second x minus the first x. So what happens in the numerator is we get 0 over negative 6. And 0 over negative 6 is equal to 0. So if you have 0 in the numerator, that means you have a slope of 0. The other thing you need to remember is if you have a slope of 0, your line is horizontal and looks like that. You have a flat slope, okay? All right, let's try another one. So we take the second y minus the first y over the second x minus the first x. Again, I'm subtracting a negative 5, so there's a double negative. So negative 7 minus 6 makes a bigger negative, so that's negative 13. And here these are going to add, so over 7. And we leave this as a fraction, negative 13 sevenths. All right, that one didn't have anything special, but let's try this next one. So we're going to take the second y minus the first y. All right, so minus 5. Okay, then we do the y2 minus the y1. So that becomes 2 minus 2. So in the numerator, 7 minus 5 is 2. And in the denominator, 2 minus 2 is 0. So this is important, you guys. We can never, ever, ever have 0 in the denominator of fraction. All right, this is not allowed. So this is actually not equal to 0. What I want you guys to write is every time 0 is in the denominator, it's undefined, which means that your slope actually looks like this. And the way that I remember this is that you cannot walk up a wall. That's a person. Okay, walking up a wall, so your slope is undefined. All right, I think we're good. Let's not do this one. All right, so I want you guys to try these on the whiteboards. Find the distance between each pair of points, and you can pause it and make sure everybody gets it using Pythagorean theorem. Okay, next one. Make sure everyone gets that one. And then we're going to find the slope between each pair of points.